Day 749 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2068. Check whether two strings are almost equivalent. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Two strings, word 1 and word 2, are considered almost equivalent if the differences between the frequencies of each letter from A to Z between word 1 and word 2 is at most 3. Given two strings, word 1 and word 2, each of length n, return true if word 1 and word 2 are almost equivalent or false otherwise. The frequency of a letter X is the number of times it occurs in the string. All right, y'all, so that may seem a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input word 1 equals a string A, word 2 equals a string B, C, C, B. The output is false. Explanation says there are 4 A's in A, but 0 A's in B, C, C, B. The difference is 4, which is more than the allowed 3. So to break this down one step further for a string, for these strings to be almost equivalent, the difference in characters needs to be 3 or less. So that means if we have 4 A's over here, we need to have at least 1 A over here, right? Because 4 minus 1 is 3. It has to be at most 3. It could be less than 3, so we could have 2 A's over here, or we could have 3 A's over here. But we cannot have 0 A's over here, and we also cannot have 8 A's over here. We can have 7 A's because 4 minus 7 would be 3, but we cannot have 8 A's over here either. So we can't have 0 A's or 8 or more A's over here, right? And since we have 0 A's, the output is false. Now, just in case that didn't make sense, let's take a look at example 2 where the output is true. So in example 2, our input word 1 equals a string A, B, C, D, E, E, F. Word 2 equals a string A, B, A, C, C. This time the output is true. Explanation says the differences between the frequencies of each letter in word 1 and word 2 are at most 3. It says A appears 1 time in word 1 and 4 times in word 2. The difference is 3. So A appears once over here and it appears 4 times over here, once right here and 3 times right here. 4 minus 1 is 3, right? So we need that fits this requirement because the difference between the frequencies of each letter is 3, and this is at most 3, and in this case it is 3, so that works, right? Because 4, once again, 4 A's over here minus 1 A over here gives us a difference of 3. Boom. Then it says B appears 1 time in word 1 and 1 time in word 2. The difference is 0. So B appears once over here and appears once over here. 1 minus 1 is 0, which is less than 3, so that fits. Then we have C. C appears 1 time in word 1, 2 times in word 2. The difference is 1. So we have 2 C's here, 1 C here, right? The difference between 2 and 1 is 1, so that's less than 3, so that works as well. Then we have D appears once in word 1, 0 times in word 2. The difference is 1. So we have a D right here. We have 0 D's over here. So that fits because the difference is less than 3. Once again, same with E. E appears 2 times in word 1, 0 times in word 2. The difference is 2. So we have 2 E's over here, 0 E's over here. Still, the difference is less than 3, so it works. And then F appears 1 time in word 1, 0 times in word 2. So we have an F right here. We don't have any F's over here, but once again, 1 minus 0 is 1, which is still less than 3, so that works as well. And since all of these letters over here fit the requirement, the output is true. Boom. Now let's take a look at example 3. So in example 3, we have our input word 1 equals string C, 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 D, D, A, B, B, A. Word 2 equals a string B, A, B, A, B, A, B, A, B. The output is true. Explanation says the differences between the frequencies of each letter in word 1 and word 2 are at most 3. It says A appears 2 times in word 1 and 4 times in word 2. The difference is 2. So we have an A right here and an A right here. It appears twice. Then we have 4 A's over here, right? But 4 minus 2 is 2, which is still less than 3. So the A's fit the requirement. Let's check the B's. B appears 2 times in word 1, 5 times in word 2. The difference is 3. So we have 2 B's right here. And we have 5 B's over here. Once again, 5 minus 2 gives us 3, which we can have a difference of at most 3. So that still fits the requirement as well. So B passes the check. Then we have C. C appears 3 times in word 1, 0 times in word 2. The difference is 3. So we have 3 C's over here, 0 C's over here. However, 3 minus 0 has a difference of 3, so that fits the requirement as well. And finally, last but not least, we have D. D appears 2 times in word 1, 0 times in word 2. The difference is 2. So once again, we have 2 D's right here. We have 0 D's over here, but 2 minus 0 is 2, which is less than 3. So it fits that requirement as well. So in the end, the output is true, y'all. So boom, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we need to do is we're going to create a dictionary used to track the frequency difference between characters in word 1 and word 2. So we're going to declare a variable called dict, and we'll set that equal to a dictionary. Key will be a character. The value will be an integer, and we'll initialize it with 2 parentheses like that. Now we're going to count the frequency of each character in word 1. So we're going to say for char in word 1, we'll open up the brackets, and we're going to increase the count for the current character. So we're going to say dict square bracket char, comma, default, colon, 0, come outside of that, plus equals 1. Now what this does right here, each time we see this character, we're going to add this character to this part, to this key of the dictionary, and then over here, we're going to keep count, right? That's why this is an integer, because this is going to keep count how many times we see this character, right? And that's what this plus equals 1 does. We're going to increment this count every time we see this character. Boom. Now we're going to do the same thing for word 2, and we're going to, except this time, we're going to subtract the frequency of each character in word 2. So this time, we'll come underneath that and we'll say for char in word 2. We'll open up the brackets and we're going to say dict square bracket char, comma, default, colon, 0. This time we're going to say minus equals 1. So each time we see this word in word 1, we're going to add to the count. Excuse me, each time we see this character in word 1, we're going to add to the count. And each time we see the character in word 2, we're going to subtract from the count. Then we're going to check that the absolute difference for every character is less than or equal to 3. If all character differences satisfy this condition, then the words are considered almost equivalent. So we could come underneath this for loop right here, and we could say return dict dot values that all satisfy. Open up the brackets, passing ABS. Open up the parentheses, $0, come outside, come outside of those parentheses, and we're going to say less than or equal to 3. Boom, y'all, that should be all she wrote. Let's give it a run, make sure it runs properly before we submit it. Okay, we got our compile error. So let me see. What is the problem? Oh, equal white space, y'all, equal white space. Let's run it again. See if that did the trick. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I'd like to see, y'all. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.